When configuring SD-WAN policies using the web interface, you are guided into a wizard-like workflow. That workflow begins with creating policy objects, so let's start there, except using Python code. Building SD-WAN policies is a long, complex process, so I've broken it into several clips. Our first task is to create the policy objects, so let's explore the updated Cisco SD-WAN.py module. I'll jump down to the Routing Policy Management section. First, we see an internal helper method named _add_policy that is used to add a generic policy object. The nice thing about the SD-WAN API is that all policy objects are added in roughly the same manner with roughly the same response data. Every object has a type, unique name, and arbitrary list of entries representing the values. The descriptions are fixed as desk not required, so we don't need to supply it. To create objects, we issue a post request to the policy/list/whatever object type. This includes the dictionary we just created, encoded as a JSON body. Let's look at some specific examples below. We'll be adding 3 policy objects today: a site list, a VPN list, and an SLA class. Each function is short and simple thanks to the helper method we just reviewed. The add_policy_site method requires a name argument along with a site list, which is a list of integers. Remember that each site has an integer ID, and we'll use that to build the proper HTTP body. Using a Python list comprehension, we iterate over the site list, converting each element to a string and embedding it into a one-key dictionary. The key name is site ID, and this list will become the entries list we must pass into the helper function. For those not familiar with list comprehensions, the code in the callout shows an equivalent solution for a classic for loop. List comprehensions allow you to compact your Python code for simple iteration tasks when your main goal is to create a new list. Last, we call the add policy helper with an object type of site plus the name and entries list we just assembled. Next, we will add a VPN list. The word VPN in this context relates to multi-tenancy, effectively building virtual routing tables for control plane segmentation within the fabric. It's conceptually identical to the add_policy_site method. First, we use a list comprehension to loop over the VPN list of integers, converting each to a string and building a one-key dictionary. Both the dictionary key and object type are set to the string VPN. We call the same internal helper and pass in the required values. Last, let's explore the add_policy_SLA class. This one has less logic because it requires more complex input. I could have reversed that, but for variety, I wanted to demonstrate an alternative approach to writing methods. The caller must include a complete list of dictionaries containing all SLA classes to add. Specifically, you can specify latency, loss, and jitter, and notice that the integer values must be strings. In the interest of brevity, I didn't add error checking to these methods, and the code simply calls the add policy helper using an object type of SLA with the inputs received. We'll test this in chunks. Like the SDK, the build vSmart policy.py script will grow over time, and this is how we'll test it. Let's explore that file next. As always, we import our SDK so we can access the methods we just wrote. Let's jump into the main function next. We use the SD-WAN variable to access the DevNet reservable sandbox as we always have. As you'd expect, we'll be calling each of our 3 policy-related methods. First, we add a site list named West US, representing the US West Coast sites. In the slides, I mentioned we would use sites 200 and 300 for this, each of which contains a single WAN edge device. This post request returns a JSON structure shown in the callout, and the field we care most about is the list ID. This is how we can reference the newly created object in the future. We'll store that in the site ID variable and print it out using a status message. This will make it easier to update or delete the object later if we are tinkering manually. Next, let's create the VPN list the same way. I'll create an engineering VPN with an ID of 1, then store the list ID in the VPN ID variable. If we wanted to be fancy, we could create multiple engineering VPNs by adding more numbers to the list. We could also create more VPN lists to represent additional tenants like HR, finance, manufacturing, and sales. We'll keep it simple for today. Last, let's create the SLA class. This time, the input is more complex as we need to specify the latency, loss, and jitter in a list of dictionaries explicitly. This is the voice SLA class, and as I said in the slides, these are well-known industry thresholds. We'll store the list ID in the SLA ID variable and print it to the console. Let's run the script to create these objects using the Python command shown. As expected, we see 3 lines of output. We successfully created the site list, VPN list, and SLA class without issue, and now have access to each object ID. I'll manually delete these objects as we'll keep recreating them as we build up our final policy. Coming up next, let's create our network topology and application routing policy.